right, this is page B1. And we talked about the difference between a linear and exponential equation the other day, and we talked about some of the key words that let you know whether or not you're dealing with a linear or an exponential. But I want to get you started on this today together, and then I'll have you finish it. So there's 5 parts. A, is it describing a linear or exponential relationship? That's the first A. B is what keywords helped you decide that. So we're going to be analyzing the words. That's because this is quantitative literacy, and that's what we do. C, which equation would be used to solve it? So is it a y equals mx plus b? Remember, this is linear. This is your only linear option. Now, these two are both exponentials, but what's a really easy way to decide that you're going to use this one right here? Right, if you're given a percent, it's going to be that formula. And then you're going to write the actual equation. D, is this an example of an increasing or a decreasing situation? And what words, because again, this is quantitative literacy, so we study words along with math. Number 1, Archimedes is draining his bathtub. Now, those English words actually mean something to us in math. He started with 28 gallons of water. Every minute that passes, 7 gallons of water are drained. So the first thing we want to do, part A, is we want to describe if Archimedes' situation is linear or exponential. The best way to do that is to decide if it's exponential, and if it's not exponential, by default, it's got to be linear. So let's just kind of go down the line. Does it have a percentage in the Archimedes problem? No, so it cannot be that. All right, for the next one, which is right here, it's going to have some words that either mean multiply or divide. So in other words, it's going to either have to have double or triple or quadruple or 1/2 or a quarter or a third. Do we hear any of those kind of words with Archimedes? No. So by default, it's going to be linear. Another thing about linear equations is they have a consistent change. That's the best word to put it. All right, so is the problem linear or exponential? A, the answer to that is linear. B, what keywords helped you determine that it was linear? Now, this is a little bit harder because we actually just used the words that were not there to determine it was linear, more so than the words that were there. But are there any words that helped you decide this is probably something with a constant change? That's okay, very good. Every minute. Every minute is indicating to us that it's doing the same thing in a consistent fashion. That's a little bit different than exponentials. Now, you might have put something else on that line. What? Drained. Okay, that's fine. Drained would have worked too. Drained's going to be an answer to the other question, so I didn't put that one there. All right, C, which equation would be used to solve, and write the actual equation. So we know on the line here, you put y equals mx plus b, and then over here, we're going to write the actual equation using the numbers with Archimedes. So it's going to be y equals, and we have 2 numbers. We have 28 gallons and we have 7 gallons. So those are our 2 numbers. Now, we learned the other day that m is the number that changes, okay? M, I'm going to write that down. M is your slope, and it changes. And B is your initial value or your starting value, and it's also your y-intercept. So just remember this from our notes. All right, so let's look at our 2 numbers, 28 gallons of water or 7 gallons. Which one of those is the one that changes? Well, okay, it's kind of tricky. Let's do initial value. How much water did Archimedes start with? 28. Is it a positive 28 gallons or is it a negative 28 gallons? Positive. So we know that the back number is going to be 28 because that's how many he started with. Now that lets me know that 7 must be my slope. Now think about it. 7 is changing because after 1 minute, you've lost 7 gallons. After 2 minutes, you've lost 14 gallons. After 3 minutes, you've lost 28 gallons. After 4 minutes, you've lost, did I miss one? I missed 21. Okay, but you get the point. It's changing. Now, what is keyword here? What is that 7 gallons doing? Draining. So what kind of 7 is it? -7, and don't forget to put your X with the slope. So the actual formula for Archimedes' bathtub is -7x plus 28. There's no other options there. Okay, I guess if you put 28 minus 7x, I couldn't mark it wrong. And then D, is this an example of an increasing or a decreasing situation? Decreasing, you can just put DEC just to save yourself some writing. And what word lets you know that this Archimedes bathtub is decreasing? Draining. Very good. Now, one thing we're practicing here is there are so many different ways to say increasing and decreasing, and this is a perfect example. Draining automatically lets us know that that water is decreasing. All right, let's skip 2 and let's go to 3. So slide up, let's go to 3. I think you get the point. We'll do one of each type. The price of a gym membership is $125 per year, and the price increases 2% each year. All right, now up here, let me zoom out so I can keep the paper showing. All right, A, we have to decide if it's linear or exponential. Well, this is a dead giveaway right here. When you hear this 2%, what type of problem do you know this has to be? Exponential, because this is our only formula that involves a percentage. You can write EXP just to save yourself some time. All right, B, what keywords helped you decide that? The fact that it said 2%. This is the key to letting you know that it's exponential. It also tells you which formula to use. All right, that's the next question. C, which formula? Now, on the first line, you just write the basic formula. So it's going to be y equals a 1 plus or minus r to the x. And then over here is where you actually plug in your numbers. So we're going to plug in 125 and 2%. Now, one very important thing is that the rate must be a decimal. This is never going to change. You cannot put 2% into this equation. So what we do is we take that percent, we divide it by 100, and our decimal rate will be 0.02. You're always going to have to convert your percentage to a rate. And this comes up, we do another unit on interest. You have to do it there too. All right, so we've got our little formula, y equals a, so we're going to plug in for A. A is your starting amount. How much did your gym membership start out costing you? 125, so that goes here. And then 1, you have to decide if you're going to put a plus here or if you're going to put a minus here, and you use the reading. So Uriah, are we going to be adding to that or are we going to be subtracting? Adding, because it says increases. So put a plus. We know our rate is 0.02, so make sure you put that correctly, and then raise it to the power of x. And then D, is this an example of an increasing or decreasing? Well, this one's pretty obvious because it says the word increase. So the answer here is increase. And what word lets you decide that? The word increase. You know what I should have said? Because I made this worksheet up. I should have said, and the price goes up. That's what I should have said, because that would have been a different way to say increases. Or I could have said, and the price is hiked. Yeah, or rising. I could have said other things. I shouldn't have used the word increasing, but anyway, forgive me. All right, we're going to do one more, and then you're going to practice number 6. Let's do one of each type. All right, in 1971, there were 294,105 females in collegiate sports in North Carolina. The number of female collegiate athletes has tripled each year. All right, what word just jumped off the page when I read that to y'all? Triple. All right, that is very important. So we look at our options. A, is this describing a linear or exponential? Which one? Exponential. And what word told you that this was exponential? Triple. That is very important. Now, you've also got to know what triple means, but we'll get to that in a minute. All right, so we know it's exponential. We go and look at our options. It's either option 1, okay, this is option 1 over here, or it's option 2. But what do you have to have for option 2? A percent, and we don't have that. So it is option 1. So we're going to write down y equals A, and then put B in parentheses and raise it to the power of X. This worksheet's a little bit skinny, so you don't have a ton of room. All right, we want to write the actual equation. So we need to plug in for A. Oh, I'm on the wrong line, aren't I? Oh, no, I'm on the wrong line. Let me get my white out. I'm sorry. I'm writing it on the wrong spot. Why didn't y'all stop me? Eli, that's your job. You should have said, Miss Smith, stop. You're on the wrong line. Now my paper's going to be all wonky, and I can't even find my white out. Oh, here it is. This is a mess. All right, that was wrong, so ignore this up here. I was on the wrong line. All right, we're going to write our actual equation. Our numbers are 294, 100,000, and then that word triple. So A is your starting value. How many female athletes did you start with? 294, 105, 294,105. All right, B, we learned this yesterday. B is your multiplier, also could be your divider. But what does the word tripled mean? 3. So put a 3 here. All right, D, is this an example of an increasing or a decreasing situation? Increasing, it's going up. And what word lets you know that it was going up? Triple. That is correct, because triple means something's being multiplied by 3. If you have triplets, your number of babies is definitely going up. If you have quadruplets, the number of babies just skyrocketed. Okay, so those words mean that something is getting larger. Okay.